In this short video, we're going to learn how to solve a basic monopoly question. Let's consider a firm, Supreme, which is a monopolist in the luxury sweatshirt market. The inverse demand for their sweatshirts is given by P equals 70 minus 2Q, and their total cost function is 1.5Q squared plus 10. We're going to answer 3 questions. We're going to find their profit maximizing quantity and price. Then we're going to learn how much profit they earn at this profit maximizing quantity and price. And finally, we will compute the deadweight loss generated by this monopoly. What do we need to know to answer this question? It turns out all we need is the inverse demand curve and the firm's total cost curve. How do we solve this question? Well, for question 1, we're going to set marginal cost equal to marginal revenue and solve for Q star. So this is our sort of standard profit maximizing process. Once we know Q star, we're going to substitute it into the inverse demand to find the profit maximizing price, P star. To answer question 2, which asks us how much profit they earn, we're just going to substitute our profit maximizing price and quantity into the profit function, where the profit function has the standard form, price times quantity, which is total revenue, minus total cost. To answer that final question, how much deadweight loss do they generate, we're going to use an appropriate sketch and identify the area that needs to be computed. And we'll talk about this sketch when we get to it in a few minutes. So let's solve this question. Here's what we know. We have our inverse demand curve and our total cost curve. And the first thing we're going to find is the profit maximizing price and quantity. We know that our process is to set marginal revenue equal to marginal cost. So the first thing that we need to do is find total revenue. Total revenue is just the inverse demand, which is 70 minus 2Q times Q. Conceptually, I'm setting price times quantity equal to total revenue here, and that's our standard formula. And then we can simplify this a little and write total revenue as 70Q minus 2Q squared. Once we have total revenue, we can find marginal revenue. We know that marginal revenue is the derivative of total revenue with respect to Q. So in this case, that will be 70 minus 4Q. We also need to find marginal cost if we're ultimately going to set marginal revenue equal to marginal cost. Marginal cost is just the derivative of the total cost function with respect to Q. So taking a look at our total cost function over here, when we bring down the 2 from the Q squared term, it multiplies by the 1.5 and becomes 3. And the power is reduced by 1. And that 10 is a constant, so it drops out. So we found total revenue, and then marginal cost. With our marginal revenue and marginal cost, we can solve for the profit maximizing quantity by setting them equal to each other. So I'm going to set 3Q equal to 70 minus 4Q and solve for Q. So if I collect my Q's on the left-hand side of the equation, I have 7 of them. 7Q is equal to 70. And then dividing both sides by 7 gets me that Q star, the profit maximizing quantity, is equal to 10. Once we have that Q star, we can plug it into the inverse demand to find P star, the profit maximizing price. So P is going to be equal to 70 minus 2 times 10. 70 minus 20 is 50, so P star is equal to $50. So we solve for the profit maximizing quantity of 10 and the profit maximizing price of $50. The next thing we're going to find is the monopolist's profit at the profit maximizing price and quantity. Just as a reminder, our formula for profit is price times quantity minus total cost. All we need to do is evaluate this profit function at a price of 50 and a quantity of 10. So I'm going to start rewriting profit. Profit is equal to price times quantity minus total cost, where total cost is 1.5 Q squared plus 10. Now I'm going to fill in what I know about price and quantity. So profit is equal to 50 times 10 minus 1.5 10 squared plus 10. And we can do this in a lot of ways. I'm going to deal with the parentheses. 10 squared is 100. 1.5 times 100 is 150. and 150 plus 10 is 160. So we have minus 160, and 50 times 10 is 500. That means that profit is equal to 500 minus 160, which is equal to 340. So we have now solved for the monopolist profit at the profit maximizing price and quantity. The final question we're going to address is, what is the deadweight loss generated by this monopoly? Before we can really answer this question, we need a sketch, and in particular, we need a sketch of the marginal revenue curve, marginal cost curve, inverse demand curve, as well as labels for our profit maximizing price and quantity. So we're going to graph this marginal revenue and marginal cost curve. We're going to label their intersection. We're also going to graph the inverse demand curve. If we graph, this is what we get. So notice the demand curve runs from 70 to 35. Where is that coming from? That's coming from this equation right here. The marginal cost curve is 3Q, so it's just an upward sloping line. And the marginal revenue sits below the demand curve, and it runs from 70 to whatever 70 divided by 4 is. My brain's tired. So we graph these lines, and I carefully highlighted the area that is deadweight loss. It's this green shaded region right here. So we need to compute the area of this triangle. We already know that the price is 50. So I'm talking about this price right here, and that the quantity sold by the monopolist is 10, but we're missing two important values if we want to compute the area of this triangle. We need to know B in particular. We need to know what this value is, and we need to know A because we need to be able to figure out the base of the deadweight loss triangle and the height of the deadweight loss triangle. So we're going to start by finding the competitive quantity, which is point A. So if this market happened to be perfectly competitive, then we know that the marginal cost curve is functionally the supply curve, and we would set supply equal to demand. So that's what we're going to do. We're going to set marginal cost equal to inverse demand and solve for Q, and that Q will be the competitive quantity. So the marginal cost here is 3Q, and I'm going to set that equal to 70 minus 2Q. Rearranging, I get 5Q is equal to 70. Dividing both sides by 5, I get that QC, the competitive quantity, is 14. So that point A occurs where quantity is 14. We also need to find the value of B. B happens to be the point along the marginal cost curve where output is 10. I can see that from the dotted line associated with the profit maximizing quantity for the monopolist. So I track that line up. I see that I need to know this point right here, the point where marginal cost, we need to find the marginal cost when quantity is 10. This is a simple exercise. All I'm going to do is actually evaluate the marginal cost curve at 10. What does that mean? I plug in that Q equals 10. So the marginal cost is equal to 3 times 10 or 30. So that means that B is equal to 30. Now that we have our missing values for A and B, we have all of the required points on the deadweight loss triangle, and we can compute that deadweight loss. So the deadweight loss is going to be equal to 1/2 50 minus 30. So I'm talking about the sort of length of the base of the triangle here, times the height of the triangle, which is this direction, and the height of the triangle is 14 minus 10. So we have 1/2 times 20 times 4. 1/2 times 20 is 10, and 10 times 4 is 40, so our deadweight loss is $40. Computing the deadweight loss triangle always is going to require finding these missing values. The missing values are always going to be the same. It's going to be the competitive quantity and the price that makes marginal cost, the marginal cost evaluated at the monopolist's quantity. That's how we'll describe it.